Julau-san. Start tayo mga 6:05. Okay, so start na tayo. So yung topic natin ngayon is DC circuits and AC circuits. So familiar naman ata kayo na yung electrical engineering professional complex is 45% ng, average natin sa board exam. So kailangan natin 'tong seryosohan. So for DC circuits, first kailangan muna natin pag-usapan yung resistance. So 'pag sinabing resistance, ano ba ibig sabihin? So yung resistance natin, yan yung ability ng material or property of material. Sige, property of materials which opposes the flow of electricity. So for example, ito yung electrons natin. So nagpo-flow siya dito. So yung resistance natin, siya yung nagta-trap or siya na yung nag-o-oppose para mag-flow yung electron. So yung formula natin for the resistance is meron tayong R is equal to rho L over A. So yung length na yung L natin dito is yung length of the conductor. And yung A natin is the area or the cross-sectional area of the conductor. So ano naman yung rho dito? So yung rho dito is the resistivity of the material. So for example, yung material natin is copper. So may resistivity siyang given. So proceed tayo dito. So question number 1. The resistance of a rod does not depend on. So ano ba siya? Letter A, the shape of its cross-sectional area. B, its length. C, its material. D, its temperature. So, ibig sabihin, ganito. Pinag-uusapan dito is yung resistance. Resistance. So, ibig sabihin daw dito, does not depend na. So, ano ba yung tama sa dito? So, yung resistance natin does not depend on the shape of the cross-sectional area. So, pag tinanong naman, yung resistivity, ano naman yung sagot dito? So, dalawang klase kasi ng sagot. Yung tanong natin. Yung isa resistance, yung isa resistivity. So, pakihanap na lang yung isang question. Okay, so proceed tayo dito sa resistor color chart. So, sa board exam, may mga lumalabas pa rin naman dito kahit papaano. So, tandaan lang, kailangan lang natin 'to i-memorize. So, black, brown, red, orange, yellow, green, blue, violet, gray, white. So, para hindi tayo mahirapan mag-memorize, puwede din naman natin gawan ng mnemonics or gawin natin black, brown, eto 'di ba, black, brown, tapos Roy G. Viv. Roy G. Sorry. Roy G. Viv. Tapos gray, white. Then, 'di ba, dito yung black, mag-start siya from 0, then from brown hanggang white, so meron tayong 1 to 9. Then yung gold, silver natin, ta's kapag walang color, ibig sabihin wala siyang first digit. So, for example, meron tayong 4 bands. So, yung first digit natin or first color, yan yung unang digit. First digit, then yung second band, yan yung second digit, pangalawang digit. Then, yung pangatlo, yan yung magiging multiplier. Then yung pang-apat naman, yan yung magiging tolerance natin. So, for example, sa case na 'to, 'di ba yellow? So, yellow, so meron tayong 4, first digit. Then sunod niya is ano 'to, violet. So, meron tayong 7, tapos multiplier, meron siyang multiplier na red. So, 'di ba yung red is 2 kung naka-digit siya. Pero 'pag multiplier, tandaan niyo na lang para hindi tayo mahirapan, kung ano yung digit, yan yung magiging exponent natin. So, times 10 raised to 2, tapos yung tolerance natin which is white. So, dito sa case na 'to, white, so wala, ibig sabihin, wala siyang tolerance. So, therefore, yung ano natin, resistance is 47 times 10 raised to 2 ohms, or ilan ba 'to? 47 times 100. So, yan siya. So, paki-memorize na lang 'to kasi importante din naman 'to. Check ko lang siya. Okey, so medyo mahaba yung topic na 'to, so medyo bibilisan ko lang. Okey. So ito, last September 2019. What is the value of the resistor with color coded green, blue, red, gold? Yan siya. Okey. So sa case na 'to, meron tayong 4 van. So meron tayong 4 na color. So ibig sabihin, yung first digit natin then second digit, multiplier, and tolerance. So first color natin green. So anong number yung green? Sige nga, try nga natin. Black, brown, Roy, G, Viv. So meron tayong 0, 1, 2, 3, 4, 5, 6, 7. So yung green natin is 5. So meron tayong 5. Then next, blue. So meron tayong 6. So 6. Then red ulit. So times 10 raised to, ilan nga yung red natin? Red, 2. So raised to 2. Then yung tolerance niya is gold. So 'pag gold, ilan nga yung tolerance natin? Meron tayong plus minus 5%. So sa case na 'to, ano yung magiging sagot natin? So, 'di ba 56 times 100, then plus minus 5%. So 56 times 100 is 5,600. So plus minus 5%, so letter D yung sagot natin. Okay, proceed tayo sa number 3. So this question is last April 2017. So sabi dito, what is the resistivity constant in 10 times 10 raised to negative 8 ohm meter of a material with a diameter of 0.7 mm and with a length of 30 meter if the material resistance is 3 ohms. So first, sige, gawan natin yung mga given. So sabi dito yung diameter is equal to 0.7 mm. Then yung length natin, meron tayong 30 meter. Then yung resistance naman natin Yung R natin is 3 ohms. Ano ba yung pinapahanap? The resistivity? Pro. Resistivity. Okay, so paano natin siya mahanap? 'Di ba meron tayong formula kanina? Sabi, yung R is equal to rho L over A. So first, 'di ba naka-ano siya, sabi dito naka-ohm meter. So kailangan naka-meter din tayo. So convert natin 'to into meter. So 0.7 mm kapag kinonvert natin siya into meter, multiply lang natin siya by, so ang 1 meter meron tayong 1,000 mm. So cancel 'to, cancel din 'to. So ang sagot dito is naka-meter na 'to. Next, hanapin natin muna yung area. So ano ba yung area ng wire natin, yung cross-sectional area? Area ng wire is pi over 4 d squared. So sa case na 'to, pi over 4 times ano ba yung diameter natin? 'Di ba given siya 0.7 times 1 over 1,000, then raise to 2 natin siya. So kunin muna natin yung area. So yung magiging area nito kapag kinalculate natin, so magkakaroon tayo ng 3.8485 times 10 raised to negative 7 meter squared kasi naka-meter squared tayo. Then apply na natin. 'Di ba? Yung R natin is 3 ohms. Then yung rho natin, yun yung hinahanap. Then yung length natin is 30 meters over 3.8485 times 10 raised to negative 7 meter squared. So may maka-cancel dito na isang meter. So matitira na lang meter. So kapag nag-cross multiply tayo, sige use natin yung calcu. Okay. So 3 times 3.8485 times 10 raised to negative 7. Then divide natin siya by 30. So makukuha natin is 3.84. So yan yung tama sa sagot. Letter D. Okay. So proceed tayo dito sa question number 4. A copper wire is drawn down such that its length is doubled, but the volume remains the same. What is the new resistance of the wire? So, sabi daw, kahit eto, 'di ba for example, ito yung wire natin, then inunat daw siya, pero yung volume niya is constant pa rin. Yung volume remains the same. So, ano mangyari lang? Okay. So, sabi dito yung V2 is equal to V1. So, let natin yung V2 is yung volume 2, then yung V1 natin is yung original volume. Then yung L2 natin daw is naging twice ng original na length. So, let natin yung original resistance natin is R1, then yung new resistance natin is R2. Ito yung pinapahanap. So, ano yung magiging solusyon natin dito? So, kung the same pa rin yung ano natin, yung volume, so therefore okey, by the way, di ko pala nasulat, yung resistance natin meron tayong formula na R rho L over A. So, puwede din natin 'to i-re-write or gawing rho L squared over volume or by dimensional analysis or unit analysis, 'di ba yung length natin naka-meter, for example naka-meter siya 'no, then yung area natin is naka-meter squared. So, dapat ang maging resulta niya is 1/m. So, dito, so kapag in-squared natin yung length, so magkakaroon tayo ng m squared. Then yung volume naman is m cube. So, therefore 1/m pa rin yung dimension natin dito. So, ito yung gagamitin natin. So, R2 is equal to rho L2 squared over V2. Then yung R1 naman natin is equal to rho L1 squared over V1. Then divide lang natin siya parehas. So, R2 over R1 is equal to rho L2 squared over V2 over rho L1 squared over since V1 is equal to V2, so puwede ko na pala ilagay dito na V2. Then maka-cancel na 'to. Cancel din yung rho. So, ano yung matitira? Magkakaroon tayo ng R2 over R1 is equal to L2 squared over L1 squared. Pero take note that si L2 natin, sabi natin is equal siya kay 2L1. So, R2 is equal to 2L1 squared over L1 squared. Then, R1 pala dito. So, R2 natin is equal, so 4 L1 squared over L1 squared times R1. So, maka-cancel yung L1 natin. So, therefore, yung R2 natin is equal to 4 R1. So, meron tayong letter B. Okay, so proceed tayo sa variation of resistance with temperature. So, ito yung magiging formula natin. So, hindi pa nade-derive kasi naka-derive lang naman. So, yung R2 natin is equal to R1 plus 1 plus alpha times the quantity T2 minus T1. So, ano ba yung R2 dito? Yan yung resistance at temperature T2. Then yung R1 naman natin is the original resistance at original resistance T1. Then yung alpha naman natin is the temperature coefficient. Ito naman yung formula niya. Paki-memorize na lang. Alpha 1 or is equal to 1 over T1 plus T. Ano ba yung T dito? It's the inferred absolute zero resistance temperature. So, sa kada material, may kanya-kanya silang inferred absolute resistance. So, paki-memorize na lang din. Paki-hanap ng iba pa. So, apply natin siya sa example. The resistance of the copper field winding of a DC machine at 20 degrees is 0.2 ohms. After operating for some time, the resistance is found to be 0.23 ohms. Find the operating temperature. So, yung wire kasi natin, habang tumatagal, umiinit siya or yung resistance natin nagbabago based sa surrounding temperature. So, kaya kailangan natin ma-compute yung temperature or operating temperature niya. So, sa case na 'to, sabi dito is copper. So, 'pag copper naman, 'pag pinag-usapan yung copper, ang inferred temperature niya, yung T, yung absolute T, meron tayong yung T niya dito is equal ng 234.5 degrees Celsius, degrees centigrade. So, yan yung inferred temperature niya. So, sulat lang natin yung given, R1. Sorry, salakin ka. So, yung R1 natin is 0.2 ohms. R2 natin is equal to 0.23 ohms. Then yung T1 natin is 20 degrees. Then yung pinapahanap dito is yung operating temperature, which is yung T2. So first, sulat natin yung formula. 'Di ba yung formula is R2 is equal to R1 times 1 plus alpha times the quantity or yung delta T natin, which is T2 minus T1. So, para dito malito, yung T natin dito, temperature, lagay na lang natin maliit na T. Para dito ay malito. T1 at T2 minus T1. So, first, kailangan mo natin ito hanaping alpha. So, yung alpha natin is 1 over T, yung T1 natin plus yung absolute T or yung inferred temperature. So, meron tayong 1 over, first temperature natin is 20 plus 234.5. So, compute lang natin siya. So, ilan yung makukuha natin dito? Yung makukuha natin dito is yung alpha natin, meron tayong 3.929 times 10 raised to negative 3. Yan yung magiging alpha natin. Then, plug in lang natin siya sa formula. So, yung R2, ilan yung R2 natin? 0.23 equals 0.2 times 1 plus 3.929 times 10 raised to negative 3 times T2 minus 20. Then, sa case na 'to, shift solve na lang natin. So, using shift solve, makakuha natin na sagot is 58.2. So, 58.2. Yan yung sagot natin. Check natin using calcu, pakita ko sa inyo. Okay, using shift solve, 0.23 alpha equals 0.2, then parenthesis 1 plus yung ano natin, temperature, 3.929 times 10 raised to negative 3 times alpha x minus 20. Then parentheses, then shift solve. So, meron tayong 58.2. Okay, so proceed tayo sa next. So, proceed tayo for Ohm's law. So, ano ba ibig sabihin ng Ohm's law? Sabi dito, at a given temperature, the potential difference V between any 2 points sorry, excuse me. At a given temperature, the potential difference V between that any 2 points on a conductor is directly proportional to the current. So, ito yung V is directly proportional to current flowing through them is constant. So, yan siya. So, therefore, yung V natin is equal to V equals to IR. So, proceed tayo for the series and parallel resistance. So, kabisado nyo naman ata 'to. So, for the series resistance, so let's say R1 'to and R2. Then, let natin 'to as Rn. So, 'pag series, para makuha yung total resistance, RT is equal to R1 plus R2 plus R3. Then, yung current naman dito, yung I1 or yung I total natin is equal to I1 equal to I2 and equal siya kay IN. Then, yung voltage naman dito is magkakaiba. So, yung voltage dito, yung V total natin is equal to V1 plus V2 plus V3. Sa parallel naman, parallel resistance, so let's say, ito yung resistance natin. Connected in parallel, R1, R2, Rn. So, kung gusto natin hanapin yung total resistance, so ito yung formula niya, 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over Rn. Then, take note din na yung voltage dito is the same. So, V total natin is equal to V1, V2, and Vn natin. Then, yung current naman dito is magkakaiba. So, therefore, yung I total natin dito is equal to I1 plus I2 plus IN. So, kaya yung parallel connected natin is tinatawag na current device tama, current divisor or yan siya. Yan siya. Okay. So, apply natin siya into sample problem. Check ko lang ulit, baka na-DC ako. Okay. Okay, so question number 6. 2 wires made of the same material at the same length but different diameters. They are connected in series to a battery. Which of the following quantity is the same for 2 wires? Sige, try natin. Okay. So, sabi dito, connected in series na. So, kapag connected in series, ano ba yung the same? Di ba sabi kanina, yung current saka the load is the same kapag connected into series. So, therefore, letter A yung sagot natin. Okay, next. A coil of wire having a resistance of 3.7 ohms and carrying a current of 0.3 amps is parallel with an unknown resistance, through which there is a current of 1.5 ampere. Determine the total equivalent resistance. Okay. So, sabi dito, so mas maganda na ma-drawing, at least ma-visualize natin yung problem. Draw tayo ng circuit. So, sabi dito, yung isang resistor, meron siyang current na 3 ampere. Meron siyang 3 ampere. Sorry, 0.3 ampere. Then yung isa naman, meron siyang current na 1.5 ampere. Ang tanong, ilan daw yung R total? So, bale dito, yung 0.3 ampere, meron daw siyang resistance na 3.7 ohms. 3.7 ohms. So, ano yung magiging discover dito? So, alam natin na yung voltage dito, let's say V1, is equal siya kay voltage dito. Tama? So, therefore, pwede natin makuha yung resistance dito. Yung R2. So, voltage is equal to IR. So, yung V1 natin, I1, R1 is equal to I2, R2. So, ano ba yung I1 natin? 0.3. Then, yung R1 natin is 3.75. Then, yung I2 naman natin is 1.5. Then, yung R2 natin is unknown. So, compute lang natin yung R2. So, ilan yung makuha natin R2? Yung R2 natin, using shift solve. So, R2 is equal to 0.75. So, since nakaparallel sila, so, kukunin natin yung R total. So, 1 over R total is equal to 1 over R1 plus 1 over R2. Or pwede rin naman natin siya, diretso na. So, RT is equal to R1 times R2 over R1 plus R2. So, makukuha natin, magkakaroon tayo ng 0.625 ohms. So, yan siya. Okay, so question number 8 tayo. A 3 ohms and a 1.5 ohms resistor are wired in parallel. And the combination is wired in series to a 4 ohm resistor and a 10 volt EMF device. What is the current in the 3 ohms resistor? So, first, gawa muna tayo ng circuit. So, yung 3 ohms daw, and 1.5 ohms is connected in parallel. Tapos, yung combination daw nila is connected in series in 4 ohms resistor. So, 4 ohms. Then, connected daw sila sa 10 volt na device. Yan. So, 10 volts. So, let's say, Yung 3 ohms natin is yung R1. Then, yung 1.5 natin is R2. R1, R2, and R3. So, solve muna natin yung total resistance niya para makuha natin yung current. So, R total is equal to R3 plus R1 yung parallel combination ng R1 and R2. So, yung RT natin, R total, is 4 ohms plus yung R1 times R2 natin, so 3 times 1.5 over 3 plus 1.5. So, yung R total natin is equal siya kay 5 ohms. 5 ohms. So, next, solve natin yung I total. So, I total is equal to V total over R total. So, sa case na to, yung V total natin is 10 volts. 10 over 5. So, meron tayong 2 ampere. So, therefore, yung current sa 4 ohms resistor, yung current dito is 2 ampere. So, kapag pumasok siya dito sa node na to, yung R1 and R2 natin is maghahati siya. Pero hindi exactly hati. So, kung ilan yung pangangailangan niya dito. So, sa case na to, apply natin siya ng CDT, Current Division Theorem. Ano ba yung Current Division Theorem? Yung Current Division Theorem, ito lang siya. So, kung gusto natin hanapin yung current sa 3 ohms resistor, so let's say R1, so I1 yung kakanapin natin. So, I1 is equal to R2 over R1 plus R2 times I total. Para sa I2 naman, I2 is equal to R1 over R1 plus R2 times I total. So, importante din naman to. So, kung hindi ma-memorize, pwede din naman mag-Kirchhoffs na lang kayo dito. So, hanapin natin yung I1. I1 is equal to 1.5 ohms over 1.5 plus 3 times 2. So, equal siya kay 0.67 ampere. 0.67. Sorry. Double check ko lang. Tama. 0.67 ampere. Next tayo. So, a voltage divider of 2 resistors is designed with a total resistance of the 2 resistors equal to 50 ohms. If the output voltage is 10% of the input voltage, what are the values with 2 resistors in the circuit? So, apply tayo dito ng voltage division theorem. Okay. So, sa case na to, sulat ulit tayo ng circuit. Sabi daw, let's say ito yung V total natin. Then, itong part na to, ito yung magiging V out natin. So, try muna natin, ito yung magiging V out. Then, yung isa naman, yung magiging V in natin. So, sabi dito, connected in series. So, yung R total natin is equal to R1 plus R2, which is equal to 50 ohms. So, para mahanap natin yung voltage dito, so let's say ito yung V2 natin, then dito is yung V1. So, V2 is equal to R2 over R1 plus R2 times V total. So, meron ba tayong R1? Wala tayong R1. Pero, meron tayong R1 plus R2. So, therefore, yung V2 natin or yung V out natin, V out is equal to R2 over 50 times yung Vin. Ano yung Vin natin? Sabi dito, the output voltage is 10% of the input voltage. So therefore, 0.10 Vin is equal to R2 over 50 times yung Vn natin. So, cancel yung Vn natin. So, 50 times 0.10. So, meron tayong 5 ohms. 5 ohms. So, yung isa 5 ohms. Ano na lang kulang? So, yung R1 natin plus R2 is equal to 50. So, kung nakuha natin is R2 is 5. Therefore, R1 natin is 45. So, sa case na to, ito yung sagot. So, pwede naman din, kunin natin yung V1. Yun yung magiging output. So, same lang din naman. So, V1 is equal to, para instead na R2 na sa taas, R1 na siya. R1 over R1 plus R2 times V total. Then, 0.10 Vin is equal to R1 over 50. Then, yung Vin natin. So, same pa rin. Yung R1 natin is 5 ohms. Then, yung magiging R2 na natin is 45. So, same pa rin naman. So, mas taon na lang yung 5 ohms na nakuha natin. Okay, so punta tayo sa KCLN, KBL. So, pag sinabing Kirchhoff's voltage law, sabi dito, Kirchhoff's voltage law, this law states that the sum of all voltage within the loop is equal to 0. So, lahat daw, yung case, sample, kapag in-add daw natin yung lahat ng voltage sa isang loop, the result daw is 0. So, E1, i-total natin, V1, V2, V3. So, kapag in-add daw lahat ng voltage, ang sum niya is 0. Same din sa KCL. So, kapag in-add natin lahat ng current passing through a node naman dito, ano ba yung node? Ito yung node. So, kung meron tayong current dito, I1, I2, and I3, kapag in-add daw natin ito lahat ng current, the result is 0. Siya. So, take lang natin ng 1 hour tong DC circuits. Then, after 1 hour, proceed tayo sa AC. Kasi sa DC kasi more on objective types lang naman siya. So, konti lang naman yung mga computation. Okay, so try natin 'to. 120 volts DC motor draws a current of 200 ampere and it's located at 1,000 feet from the supply. The copper transmission wire has a diameter of 0.45 inch and with the specific resistance of 10.4 ohm circular mil per foot. What must be the voltage of the supply source? Sige, try natin 'to i-solve. Medyo mahaba lang 'to yung solusyon. So first, kailangan muna natin hanapin yung area ng wire. Kasi kailangan natin hanapin yung resistance. So, area ng wire, meron tayong puwede natin gawin D squared. Ano ba yung D dito? Diameter in mils. So, meron tayong sabi dito is 450 mils. Kasi ito siya. Ito yung conversion niya. 1 inch. So, delete ko lang 'to. Okay. So, 1 inch is equal to 10 raised to 3 mils. So, given dito, given is naka-inch na. So, therefore, yung diameter natin, yung D is 0.45 inch times 10 raised to 3 mil over 1 inch. So, cancel yung inch. So, meron tayong 0.45 times 10 raised to 3 mils. Then, yung area naman is just D squared. So, 0.4 times 10 raised to 3 mil raised to 2. So, magiging sagot dito is in terms of circular mils. So, magiging sagot natin is 450 mils. 450 circular mil pala, sorry.